engines are PW127 from the Canadian manufacturer Pratt & Whitney. They are linked to an Hamilton Standard 6-blade constant-speed propeller. It is composed of a combustion chamber, one high-pressure stage composed of one compressor and one turbine, one low-pressure stage composed of one compressor and one turbine, 3 turbines linked to a reduction gearbox driving the propeller, one accessory gearbox driven by high-pressure stage. Right engine is fitted with an hydraulic propeller brake. It allows the engine to run without propeller rotation to generate DC electrical power and air conditioning. This engine operation is called hotel mode. Power is managed by power levers, condition levers, and power management. PL manages engine power through an electronic engine controller that controls fuel flow via the hydromechanical unit. Propellers are managed by CL through propeller electronic controller. Power management adjusts torques and propeller speed settings regarding flight phases. Engine fuel supply is composed of low pressure valve controlled by fire handle. Fuel heater uses engine oil to increase the fuel temperature coming from the tank. High pressure pump to increase pressure in the duct according to engine needs. High pressure fuel filter is monitored for clog detection and fitted with a bypass. HMU controls fuel flow on EEC order. HMU high pressure valve is controlled by CL for fuel shutoff. A fuel flow sensor sends information to pilot instruments. All circuit is composed of an oil tank, an oil pressure pump, an oil filter, a fuel heater, an air oil cooler. Oil is dispatched inside the engine, then redirected to oil tank. Each engine is equipped with 2 high-energy ignition systems, A and B. Each high-energy ignition system is composed of an ignition exciter, a spark igniter. If needed, the system can be activated manually. The engine air intake is designed to provide inertial separation and protection in the event of foreign object ingestion. It is also used to divide airflow in a primary flow directed to the engine and a secondary flow directed to the oil cooler. The propeller control system uses the condition levers and the power management selector via the PEC and the power lever to activate the pitch change mechanism through the governors and associated equipment. Propeller pitch change is actuated by engine oil. The system is protected against low pitch angle in flight, overspeed, hydraulic pressure loss. The right-hand propeller reduction gearbox is provided with a brake to be used on ground for hotel mode operation. An EEC provides control of fuel flow in the HMU through a stepper motor in such a way as to control the torque in accordance with outside conditions and positions of the power lever. The power management. The bleed valves. The HMU provides a fuel flow which generates the HP compressor speed. The PEC is a dual-channel electronic box, which provides closed-loop control over the propeller pitch change system. The PEC detects, isolates, and accommodates systems faults. In the event of a failure of the primary channel, control of the propeller system is automatically transferred to the backup channel. Propeller speed is calculated by the PEC. EEC manages the fuel flow. Both manage the torque and NP sensors. EEC gives altitude and airspeed data information to PEC. Power management controls PEC, feedback loop for PEC monitoring. Condition levers gives order to PEC, feather, auto, and 100% override positions, and HMU, fuel shut-off position. PEC controls propeller pitch. Pilot controls are power levers, condition levers, and power management. Engine power is controlled through power levers with different positions. Max reverse. Ground idle. Flight idle. Notch. Max rated takeoff. Forward stop, wall. Condition levers have 4 fixed positions. Fuel shut-off, feather, auto, 100% override. A power management rotary selector with 4 positions. Takeoff, maximum continuous thrust, MCT. Climb, cruise. According to the different flight phases, it controls NP, and also target torque provided power levers are in the notch. The engine management systems are located in the cockpit as follows. Power levers, condition levers, power management, EEC, PEC. The engine parameters are displayed on EWD and SD secondary engine page. On EWD are displayed torque, NP, ITT. On SD secondary engine page are displayed oil pressure and temperature, NH, NL. On ground, PL normal position is ground idle. Moving backward reaching taxi then reverse area. Taxi and reverse areas are spring-loaded to ground idle. Flight idle position can only be reached when gust lock is off. When airborne, idle gate locks ground area to prevent power lever reduction below flight idle in flight. In notch position, torque is driven by power management regarding flight phase. Ramp position gives 100% of available power. Wall position is only used for emergency. To retard to ground idle, power lever must be set to flight idle, then toggle switch must be pressed and idle gate retracted to unlock ground area. Idle gate is automatically retracted when aircraft is on ground. Condition lever's first position is fuel shutoff. Second position commands propeller pitch to feather position. It also allows fuel flow to reach the engine. In auto position, NP is adjusted by power management regarding flight phases. 100% override position sets manually NP max. Condition levers fuel shutoff, feather, and auto positions are locked, except from auto to 100% override and back. Trigger must be pressed to unlock condition levers. To start the engine 2 in hotel mode, engine start rotary selector must be set on Start A, Start B, or Start A and B positions. Then, associated start push button must be pressed to energize starter. Once NH above 10%, set condition levers to feather. When start is complete, set engine start rotary selector to off. Notice that ITT disappears on SD secondary engine page. The right-hand engine is fitted with an hydraulic propeller brake to be used on ground for hotel mode operation. Green light on propeller brake panel indicates that propeller brake is ready to be engaged or disengaged. Ready light is available when aircraft is on ground. Gust lock is on. Engine 2 condition lever is set to feather or fuel shutoff. Blue hydraulic system is pressurized. Fire handle is not pulled. Power management in takeoff position. Power lever in the notch and condition levers in auto. Torque is automatically set to takeoff power, and NP is automatically regulated to 100%. When power management is set to climb, torque is automatically set to climb power, and NP is automatically regulated to 82%. When power management is set to cruise, torque is automatically set to cruise power, and NP is also regulated to 82%. Power lever are retarded for descent, no change on power management neither on NP. Power management is set to takeoff position in approach. NP remains regulated at 82%. If high power is requested, NP will be regulated at 100%. When MCT is set on power management, NP is automatically regulated to 100% and maximum power is available. To help pilot in case of engine flame out during critical flight phases, ATR 72-600 is fitted with automatic takeoff power control system. ATPCS is used to automatically manage engine and propellers in case of engine flame out with power management in takeoff position. ATPCS is armed with following conditions. Power management to takeoff. ATPCS push button on. Both power levers angle more than 49 degrees. Both torques greater than 46%. In case of engine failure during takeoff, ATPCS will adjust power on live engine to maximum power, set feather on failed engine, and close both bleed valves. In case of engine failure during go-around, ATPCS will only feather failed engine. In case of EEC fault, detection, master caution, and single chime are triggered. Local alert displays fault in amber on the affected EEC panel. On alerting window, engine EEC in amber is displayed. When EEC is fault, the power is managed by the power levers directly linked to the HMU. In case of PEC fault detection, master caution and single chime are triggered. Local alert displays fault in amber on the affected PEC panel. On alerting window, engine 1 PEC in amber is displayed. PEC system is fitted with 2 channels. In case of PEC single channel lost, the associated checklist will be triggered, but the PEC is still available on the backup channel. In case of idle gate fault detection, master caution and single chime are triggered. Local alert displays idle gate fail in amber on the affected panel. On alerting window, idle gate in amber is displayed. Idle gate must be managed manually. The engine oil system is fitted with sensors as follows: an oil low pressure switch, an oil pressure transducer, an oil temperature sensor, in case of engine oil low press detection, master warning and continuous repetitive chime are triggered. Local alert are displayed on SD secondary engine page. On alerting window, engine 1 oil press in red is displayed. In case of abnormal propeller brake detection, master warning and continuous repetitive chime are triggered. Local alert displays unlock in red on the propeller brake panel. On alerting window, propeller brake in red is displayed.